Other number systems, the base 2 number system. As stated earlier, we use a base 10 number system, hence the name decimal, where we use 10 different digits to write all numbers. However, the decimal system is not the only number system used in practice. For example, computers use the base 2 number system to operate. This is done only for convenience, as it is much easier for the machine to handle 2 types of input signals rather than 10 different ones. Hence, computers are built in such a way that they recognize only 2 types of input voltages: 0 volt, this means 0 input or no input, or 5 volt, this means maximum input. The computer then converts the 0 volt input in a number form. The 0 volt input appears on the screen as the digit 0, and the 5 volt input is shown on the screen by the digit 1. Hence, when you see a number on a computer screen like this following example shown on screen, it is important to understand that there are 8 consecutive inputs on the computer produced by the power source that are interpreted as the following shown on screen. However, this is not the point we want to discuss, as we are here to explain how this base 2 system, also known as binary system, is related to the base 10 system we use in our everyday routine. Hence, we can say that basically, the logic of base 2 number system is similar to base 10 number system. The value of digits increases from right to left, just in the decimal system. The only difference is that in the base 2 number system we use only the digits 0 and 1 to write all numbers instead of 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 that we use to write numbers in the decimal system. In this way, a binary number does not have ones, tens, hundreds, thousands etc., but ones, twos, fours, eights, and so on. In addition, a binary number can be decomposed in powers, but this time in powers of 2 instead of in powers of 10 as occurs in decimal numbers. Thus, if we read the number in the following shown on screen, we can decompose it as 1 times 2 to the power of 7 plus 0 times 2 to the power of 6 plus 1 times 2 to the power of 5 plus 1 times 2 to the power of 4 plus 0 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 0 times 2. To the power of 1 plus 1 times 2 to the power of 0. We can find which number in the decimal system the previous binary number does correspond. Thus, doing the operations, we obtain the following shown on screen. Example 1. What number in the decimal system does the number 1001001 correspond? Solution 1. We have the following shown on screen. We can also convert a decimal number into a binary one, by dividing it recurrently by 2 and then taking all remainders of division from the last to the first, to write the corresponding binary number. Example 2. Write the binary form of the base 10 number 157. Solution 2. We have the following shown on screen. Thus, taking the remainders from the last to the first, we obtain the following shown on screen. The proof will be shown in the following on screen. Hence, the solution was correct. That is all for lesson 1.7.3. To continue this tutorial, please watch 1.7.4, Operations with Binary Numbers. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.